Salting. Yeah, my hash needs a little salt. So the issue that we have here is that if I have two users with the exact same password, what is their hash going to look like? It's going to be identical. Well, what we can do is we can randomize the hashes by appending or prepending random strings, we call it a salt, to the password before we hash. Now, this again helps us with having duplicate hashes, as well as it makes it really hard for an attacker to find out what's going on. Now, each salt needs to make sure that it's unique for each password. Don't use the same string of characters for every password. Then all I have to do is figure out what your salting string is, and I'm going to get everybody's password. Let's say, for example, that I've got two accounts that are both using the same password. Again, the hash values will be identical. If I use salt, I can append some unique characters to the end of the password. Therefore, two different accounts using the same password have different hash values. To check if the password is correct, we have to be able to have access to the salt, so it's usually stored in a user account database along with the hash or as part of the hash string itself. Now, I'm going to give an unfortunate shout out here because Microsoft won't use this. Well, they kind of use it in the aspect that the passwords in Active Directory are hashed, but the ending hash is just the user name itself. So again, make sure that if you're going to salt your passwords, that each salt is unique to each password. So if you're a developer and you're creating your application and you want to make it so people have to log in, common mistake is that they'll hard code in a salt into the program, or they generate the salt only once and then reuse it. Because again, if I'm using the same salt for every password, two users with the same password are going to have the same hash. There's also the issue of your salts not being long enough. Say, for example, 3 characters. Well, 3 characters really narrow down the limits of the number of possibilities the attacker needs to consider. Now, because I just told you that the hash needs to be available, that kind of creates a dilemma, right? Because if the key is kept on the system and the attacker gains full access to the system, they'll be able to steal the key no matter how long the salt is. So the key needs to be stored in external systems, such as a physically separated server dedicated for password validation. Or there's even some specialized hardware out there that can help store your salt keys. Now, if we can only add some pepper